see. So applications of flip-flops. So in this application, we are going to understand where we are going to use these flip-flops. As I told you in the previous classes, many times I am repeating this statement. The first application is what? Shift registers. Shift registers means what it contains in the shift register. So shift registers are nothing but it is using to store the data or shift the bits, sometimes left side or sometimes right side. Sir, how it is going to shift? Because the register contain collection of flip-flops. If we are going to transfer a 6-bit data transmitter, so we need a 6-bit register. So if you want to use a 6-bit transmitter, nothing but a 6-bit register, 6-bit transmitter is nothing but 6-bit transmitter is nothing but 6-bit register, shift register. So we need a 6-bit flip-flop because every flip-flop is going to store 1 bit of information as we know. Clear? Shift registers is nothing but group of flip-flop. Shift bitter registers, shift registers is nothing but group of flip-flops. Each flip-flop store single bit. Each flip-flop stores single bit. For example, here this is a register or shift register. If you take whatever it is, register or shift register. Here it is a combination of flip-flops. How many flip-flops are connected here? 6. That is why this shift register is a 6-bit shift register. Are you clear? Are you clear? Because every flip-flop is going to store only 1 bit. So 6 bit. So 6 flip-flops are connected. Are you following? Are you clear? The shift register data storing, the shift register data storing depending on number of flip-flops in the shift register. Depending on number of flip-flops in the shift register. Because this shift register contains 6 flip-flops, so that is going to store 6 bit of information. Got it? Very, very important point it is. For transferring the data, and to storing the data, we can use the shift register. For transferring the data, for storing the data, we can use the shift register. So how to store, you know already. How to transfer, we are going to learn next topic. How to store, you know. Yes or no? Every flip-flop, it is going to store 1 bit. 1 bit. That bit either 0 or 1. Yes or no? You know how to store. For example, if you wanted to give 0, 0, 1, 1, 1, 0. So it is stored in a flip-flop. Every flip-flop is going to store 1 bit. Okay, this is done. Then how to transfer, we are going to learn in the next topic immediately. Are you clear? Are you clear? So there is a three types of possibilities in the shift register. The first one, parallel to serial conversion. Parallel to serial conversion. Second one, serial to parallel conversion. Third one, data storage. Either serial or there are three possibilities. One is parallel to serial, serial to parallel for data transmission, and last one is the storing of the data, either serial or parallel. So this is a application for the flip-flop. Then I told you one more application. What is the one more application? In your syllabus, these two applications, many are there outside. So second one is the counters. Sir, what is this counter? It is going to count the number of attempts, number of clocks, how many times the clock is enabled. So wherever you want to count, whenever you want to count the attempts, so use the counter. Counters are used to count the number of pulse or number of states. Counters are used to count the number of clock pulse or number of states. Are you clear? If we want to move from one state to another state, if we wanted to move from one state to another state, we need a pulse state. We need a pulse state. Means that state is where it is. Or clock edge. Pulse state or clock edge, where it is. Either 0 or 1. Okay. That counter is count how many pulses to obtain a particular state. That counter is pulse. That counter is count. That counter is count how many pulses to obtain a particular state. Means in your class maybe we are going to select some coordinators. So 4 students are stand up. Maybe remaining students, they are giving their votes. So the counter, whenever they are giving, the counter is counting with help of pulse edge. So at a time, again, I am not going to count this lady. These are counted. No. All 4 candidates at a time it is going to count. That is going to done by counter. The best example I told you, what is the EVM machine. So whenever you are going to give mark your vote, maybe the candidates are 24, 25 candidates. Yes or no? Or 100 candidates sometimes. Even though the EVM machine is going to produce the count for every candidate. Here, understood? Counting is different. Counting the pulses of the every candidate is different. Yes or no? The best example is EVM machines are the application for the counters. Direct application. Everyone knows this. Okay? Clear? Then for this, there is a 2 possibilities. First one, count the number of pulses. Count the number of pulses. Next one, frequency division. Frequency division. Number of pulses count and frequency division, how the frequency is going on. So these are the two applications for the